Good morning, everyone. This is Kim Worley, Director of Engagement at MXD. Very excited you were able to join us this morning. I would like to say that the slides will be shared after the webinar. And so you will get those. I think that's probably one of the most common questions we get through our question box. Feel free to, if you haven't used this platform before, please submit any questions you have through the question box, and the webinar moderators will get back to you throughout the presentation, or will bubble up questions at the end during the Q&A session. So I'm going to go ahead and kick us off. Sean, if you can go to the next slide. So I want to introduce Manufacturing USA for those of you who are not familiar with it. Manufacturing USA is a network of 14 institutes across the US that were established to advance US manufacturing capabilities through public-private partnerships. It was modeled after the Fraunhofer Institutes in Germany and the Catapult Institutes in the UK that really developed, help foster and accelerate innovation across many different technology verticals. Next slide, please. I always like to introduce Steve Johnson, the author of Where Good Ideas Come From, to provide a better understanding of why institutes like MXD are valuable and important. Steve Johnson discusses where good ideas come from through his research and discovers that it's not the aha moments that we learn about in school, like when Isaac Newton had an apple fall on his head and developed the gravity theory, but rather ideas come from sitting around in cafeterias, in lounges, and individuals share failures and successes, but oftentimes solutions are developed by individuals, many individuals, couple individuals, who stitch together failures, things that didn't work. That's when collaboration occurs and solutions are developed. And so many times it's really when individuals come together and collaborate. And he discusses how the setting of where individuals are can affect the outcome and idea implementation. Next slide. So I like to introduce this Steve Johnson's research because I like to believe that MXD is the physical space where people, ideas, and technology can come together to innovate. We have a 24,000 square foot manufacturing floor for individuals across academia and industry to experience practical applications of digital technology. Our factory floor houses test beds and dozens of technology demonstrations, which includes McKinsey's North American Digital Capability Center. These are physical assets that our members can experiment on and learn about advanced manufacturing capabilities and identify pathways to implement this technology in their own factories. It's also a place for individuals to experiment and de-risk the adoption of emerging technologies. Next slide. The experimentation at MXD doesn't just center around small incremental improvements. However, they occur. They're positive byproducts of the research projects that we implement, but rather our experimentation really centers on solving very complex problems that no single organization or entity can solve on their own. And so in order to do that, MXD brings together a robust ecosystem with diverse set of subject matter experts that focus on leveraging emerging technology to accelerate productivity and really change the way manufacturers operate as we know it today. We have all heard about Industry 4.0 and smart manufacturing. We're in the midst of introducing dozens of new technologies, which are being introduced rapidly, and it seems impossible to be able to digest all that information and understand what it means for your organization. And so today, we've partnered with one of MXD's ecosystem experts, Sean Riley from Software AG, to discuss how organizations can harness the power of emerging technology like machine learning and edge computing and what that really means for your business and why it's important to embrace it. And so, Sean, I'll pass it over to you.
Thank you very much. Looking forward to the topic this morning, and thanks for having us. So, as introduced, I'm Sean Riley. I am the global industry leader for the manufacturing and transportation verticals at Software AG, and we've been looking at for a number of years now what specific technologies are enabling companies to become disruptors, and more importantly, how they've gone about doing that. And we're going to share some of those learnings with you this morning. But first, we have a couple of interesting numbers that I wanted to talk about. -12, 52, and 11.2. And they're relevant and will set the stage for our conversation. 52% of the companies listed on the Fortune 500 in 2000 have disappeared since then. So in a mere short 20 years, half of that list is gone. Some companies, like TRW, a well-known automotive supplier, fell off the list and were purchased by companies who are now on the list. Others simply didn't grow and stayed static while the market changed around them. Those companies that aren't digital or exploring digital transformation through key enabling technologies, according to McKinsey, will experience revenue losses of 12%. While those that are able to become disruptors will see revenue increases by 11.2%. But what's interesting about this is 89% of companies are deciding right now how or if they're going to disrupt the market, with 6% having determined that they're going to go ahead and stay as a disrupted company, that they're not going to explore the digital outcome. 5% have already become disruptors. So what do manufacturers typically state is in their way of becoming a disruptor? And this is according to any company or any survey that you see, whether it's from McKinsey or Boston Consulting Group or Bain, it always comes back to talent or the ability to obtain talent in these particular areas. Digital has everything to do with the art of mastering data. And some years ago, analysts started to call data the new oil to underline the strategic importance of this asset. Well, it's no surprise then that companies like Apple and Google are some of the most valuable today, outperforming companies like Standard Oil or Exxon, mainstays of the Fortune 500 list for years. Well, making products at the lowest or best quality have been the modus operandi for competing for years in the pre-digital world. But those are now table stakes to compete in the digital arena. To survive and thrive today, you not only need to have to compete on cost and quality, but you also have to add value quickly, faster than the market, by using data to innovate for increased operational excellence, focused on customer experience, the ability to capture new value, and continuously provide rapid innovation so you can delight your customer, disrupt your competition, and obtain new revenue from existing and new sources. Which means that today, data is no longer the new oil. Today, data is the new currency. Knowledge-powered businesses can also monetize their data, are the ones winning and disrupting the market as we speak. Sliding in at number 10 on the Fortune 500 list, Johnson & Johnson is the only company making a product in the top 10 most valuable companies. 7 of the top 10 are technology companies because they've mastered how to use data. And as a result, many businesses are actively working on an insight strategy using real-time capture, analysis, and distribution of data to drive insights and achieve those outcomes. But that's where manufacturers are struggling because they have data. Manufacturers are typically awash in data, but they're usually only able to leverage less than 10% of the data they have. And it's this data that also causes fractures in the organization, which is an interesting paradigm because data is also being considered the new currency. But it's not just data that's causing these fracture lines. Over time, decisions have been made improvement projects have been implemented. Mergers, acquisitions, and divestitures have occurred, and the business environment has continued to change. Manufacturers are struggling because these strategies are often split between primary and support activities. Industry 4.0 initiatives are struggling to scale, and IT/OT integration projects are proving difficult, even though the technology is capable. On one side, IT has objectives for cost cutting while modernizing the back office with agile methodologies or moving applications to the cloud. But while this might seem innovative, cost reduction is really the main goal. And when 80% of IT budgets are still focused on keeping the lights on, and with long timelines for many projects, they often don't align with the market-driven timing and goals of the business. Every plant manager has operational excellence objectives to hit. Every supply chain leader has to continually reduce costs. They cannot wait for IT. They cannot scale to serve every need simultaneously. And that's causing costs to surge into the activities that are needed to support them. Because of this, digital leaders turn to digital technology and self-service cloud applications to adapt quickly to market changes. But without the support of IT, these quick wins can come at a much greater cost if there's a security breach, or if an application can't scale or stops working altogether, or functionality is duplicated and data becomes more segmented and partitioned. That's why 80% of IT spend is still left maintaining the current state. Ecosystems aren't fully aligned to organizational needs, and customer needs can be misunderstood because sales teams conducting quarterly business reviews just aren't enough to fully understand issues and wants. Innovations from suppliers can be missed because they don't understand what the true issue is and when they need to act or how they can help the manufacturing enterprise. This doesn't just create an expensive burden for IT to maintain. It means you lose the ability to innovate and you're left behind while disruptors forge ahead, waiting to serve your customers. And this is what's called the fractured enterprise, and is the only reason why 5% of companies are reaching the digital disruption phase. You're a manufacturing company. You shouldn't mimic a tech company, but you should mimic how they treat and manage data to become a truly connected enterprise and a feared competitor. For this, you need to start thinking about your organization in terms of connectedness. And it's not just about connecting data and technology, but it also encompasses people, processes, and business models, as well as the technology. In order to bring together these business users and IT, you need to operationalize your data, linking all perspectives, triggering decisions at the point of data collection, taking the right actions at the right moment, allowing you to monetize your insights. But before you can do so, you have to be able to liberate your resources, integrate all your data in real time, whether it's about databases in-house, cloud-based APIs, or IoT at the edge. Brings together powerful information from your ecosystems and ensure data sharing is not an issue. And then finally, you have to make sure that business, technology, and IT are innovating faster together under a single governance model, and they know how to make decisions autonomously based on the overall strategy of the company. It's a lot, but when it comes together, it means business IT can align behind your business objectives, and everyone understands the impact of these initiatives across your initiatives. And that's when you've reached the heart of digital transformation. And the best is you can do it without retooling your existing talent, because you have the ability to give your existing talent the ability to leverage data on their own, the autonomy to act, and the managerial direction to support short and long-term strategy. While it's not simple, it'll enable you to truly connect the organization so that you can move faster and become a truly connected enterprise. So when you're able to turn your data into value, you're no longer struggling to survive, but you can be tomorrow's disruptor and join the 5% slide. And why is this relevant for our conversation today? Well, we're going to talk about what are some of these key technologies that are driving this disruption, and really how to use them to join that 5% club. The first two market disruptions are focused on how do I leverage IoT to create smart connected products or remotely manage key assets that I have in my production facility. And these two particular areas were part of the rise of IoT that occurred approximately 5 years ago. But as IoT is being adopted more frequently and used in wider manners, this particular area is still causing significant disruption in the marketplace as more and more benefits are found. Secondly, as manufacturers are, again, leveraging that key technology, the Internet of Things, they're looking at how can I optimize my factory? How can I pursue Industry 4.0 or smart manufacturing initiatives to make my factory paperless? And then how can I also use that to ensure I'm able to look at my logistics and supply chain networks, both from a supply perspective and from an order perspective, to ensure the entire value chain is flowing freely. But IoT isn't the only disruptive technology or concept, I should say, that's hitting the market. The latest disruption that's being seen, and it was starting to gain steam approximately 8 months ago, but 2 months ago significantly picked up, is the concept of direct-to-consumer. As manufacturers look at how can I sell products not through intermediaries, but how can I set up my supply chains? How can I set up my orders to go directly to my end consumer? End consumer can either be in a B2B or a B2C manner. B2B manner, looking at maybe I don't want to go directly through distributors, but I want to reach those end companies that are purchasing from distributors. Whereas the direct-to-consumer model from a B2C side is typical, and it's used by companies like Dollar Shave Club that stated, hey, to Procter & Gamble and Gillette, we don't need to sell through Amazon. We don't need to sell through Walmart or other key retailers. We're going to sell directly to an end consumer on a subscription basis. And then the last area of disruption is really being seen by companies that are able to create and leverage an ecosystem. And an ecosystem is a little bit different from a supply chain, whereas it's not just suppliers that are innovating on perhaps new specifications for products or consumables that are being used as part of your production process, but they're innovating on new outcomes for your customers on your behalf. And their innovations are part of a wider range of innovation. So while these are the most key market disruptions, we're going to start by focusing on smart connected products and remote asset management. And according to a leading research firm, IoT Analytics, the equipment as a service market is expected to grow exponentially between now and 2025. And the reason for that is the ability of this type of program to create revenue. And typically the revenue that is created is at a higher value than the products that are actually made, which is, I think, a little funny because many manufacturers have considered service operations to be a begrudging need to have. It's not something that's seen as a primary activity, but something that says, hey, if we're making a piece of equipment, we have to be able to service it or enable other companies to service it. But when this particular aspect is studied, McKinsey has found it's usually a much higher margin than the sale of the product itself, and is repeatable. It creates a strong, repeatable revenue stream, and it's those repeatable revenue streams that make companies more viable in the long run. It makes them less susceptible to external market disruptions. More significantly, it also ensures that, or I should say more significantly, as companies pursue IoT-enabled smart products, that they're also able to change their pricing models, to shift from a buy-lease scenario to an outcome sale. And we'll speak about that specifically as an example of a company that's done this. One company that's done this is Gardner Denver. Gardner Denver is a manufacturer of air compressors. And they looked at, we want to create an IoT strategy. How are we going to do that? And their first aspect was, all right, if we're going to really focus on creating an IoT strategy to enable products in a smart manner, we want to ensure that it supports our service operations and our consumables operations. And since we're doing this, we want to maintain not just our equipment at a customer locations, but everyone's equipment. So we need to be able to come up with a solution that allows us to do that, which means we're going to have to bring in multiple data types in multiple different data formats at speed and scale. And we're going to have to make sure that we can retrofit both our brownfield equipment and our competitors' brownfield equipment. Secondly, we want to be able to have multiple offerings, because not every customer is going to say, hey, you know what, we want you to predictively maintain our equipment, or we want to move to a outcomes as a service, or as Gardner Denver calls it, air as a service model. We want to stick with what we have. All right, fair. So we have to be able to provide 3 or 4 different options for those customers to choose from, because we want to make sure that their customer experience is tailored perfectly for them. And that means we're going to have to process analytics on the edge. We're going to have to process analytics centrally to let us know what's happening. We're going to have flexibility with that. Most importantly, we're going to have to do it quickly, because we don't want competitors to beat us to market in this particular offering. We want to be a market maker, and we want to ensure that we're able to do this reliably everywhere Gardner Denver compressors are sold and used. But here's the real trick. When they created Icon, they realized we sell through distributors. We don't want to disintermediate that particular channel. These distributors have been great business partners for years, which means they need to have access to their customers' data. We need to have access to our customers' data, and we need to have it done completed in a secure, multi-partition manner. And that's where they were able to complete this by looking at a singular cloud platform that provided true multi-tenancy, so that as they brought this IoT enabled platform to life, it had that flexibility to support that level of security and scale. But there's one key aspect that Gardner Denver needed that gets brought up a lot, and that's edge processing. And I'm commonly asked, what exactly is edge computing? Well, edge computing is a combination of being able to perform complex analytics, both on the thin edge, which is on the device level, in the fog, which can be a gateway or a remote server, and at a central location. And that central location can be in a cloud, or it can be in a data center. How prevalent is this? Well, according to according to Gartner, right now approximately 10% of IoT applications leverage edge computing, and by 2025 that number is going to increase to 75%, which is an amazingly large rate. And some benefits of that is reduced data transmission costs if it's a remote piece of equipment, as well as speed. Putting your analytics on the edge allows those analytics to be performed much faster. You're losing the latency that's involved with data transmission to a centralized analytics point, and then sending alerts or instructions back to your smart pieces of equipment. So what are some other technologies that are disrupting the market today? And the first I think we have to talk about is really a digital twin. And a digital twin is a digital representation of a physical piece of equipment. And most people commonly understand digital twins to be focused on advanced robotics or production equipment, or even a SCADA diagram that's pulling in real information, and simulations can be run through that to understand what's happening in the with that particular piece of equipment, with that what's happening with that particular production line. But digital twins have a much broader meaning. Digital twins are not just limited to products, but they also focus on what about my enterprise processes? What about my key assets? And then, of course, what about my end performance? And what's interesting about this is the same technologies that are used to create a product digital twin can also be leveraged for an enterprise asset and performance digital twin. And when you combine these technologies together, it provides significant benefits that allow companies to become disruptors in their enterprise. So examining an enterprise digital twin looks at, first off, I've got my enterprise processes. I've got my my capabilities. I know what my company is doing. I have a strategy laid out. I am executing on that strategy, and I'm creating outcomes for my own company and my customers. But when you look underneath the covers, there's a significant more amount of activities that's going on in terms of what's happening in that enterprise. And that's where an enterprise digital twin gives you specific functionality that enables you to understand how my enterprise is operating, what are my outcomes, how can I enable my personnel to work under the guise of this strategy to drive KPI performance. And if I want to make changes, how can I simulate those changes to project what my outcomes will be? And it's been used in practice before. One particular company, Philips, started this particular journey. And their initial challenge was they were making consumer products and they wanted to move to a higher margin business. But that meant they were going to have to completely transform their company to a healthcare products manufacturer. They had this huge product line and they had over 72 different go-to-market models. The environment that they operated in was extremely complex, with every region and every business unit having their own operational parameters. And their famous tagline was that they were tired of smaller competitors gaining market share because they were just faster than they were. And that was an issue where they really wanted to focus on how can we be more agile as an organization. And they did this by turning to this digital twin concept where they were able to identify their go-to-market models, rationalize them, be able to understand their value chain in an end-to-end basis, understand what activities were driving KPI performance and which ones were detracting from it, and then, of course, simulate changes quickly to be able to rationally switch to a new type of company that not only makes healthcare products, but has new performance standards, meaning they had higher levels of on time in full. They were able to reduce held inventory by greater than 25%. And more importantly, they were able to gain back their agility. They were able to be nimbler and faster than their competitors in terms of creating products that met new market requirements and distributing those products around the world. And the end result was in 2018, at the end of this particular journey, Philips was able to report a 25% increase in net margin, which is fairly significant for a company undergoing that type of transformation. The second type of real digital disruptive technology is a digital thread. And the digital thread is focused on how do I understand what's going through my entire operating environment and how can I link this together so I can have a seamless activity. So many companies have your typical enterprise assets, an ERP, a CAD for engineering, maybe multiple different supply chain management applications, and they operate great on their own. But the problem is they need to operate well together. Many companies want to be able to implement rapid prototyping using 3D printing, and that requires information to be supplied to the CAD from engineering, as well as that CAD supplying information to the 3D printing tools. And that can be done either manually or digitally. Another method is we want to, again, use our smart connected products to drive higher levels of efficiency throughout our organization. And while our field service management app can help with that, we need other supporting applications like our CRM and our ERP to be connected. And then most importantly, perhaps if we're looking at smart manufacturing initiatives on our shop floor, to be able to resolve that particular or implement those particular initiatives, we have to be able to pull in ancillary data and share data from our MES with our warehouse management system, with our ERP, with our transportation management systems to drive that greater efficiency. The ability to link all of this from your suppliers in a single, or from your suppliers to order receipt at customers in a single digital view is what's commonly referred to as a digital thread. And it's the ability to track and understand, both historically and in real time, units as they move through your operational process or as they move through the entire value chain. And companies are leveraging this technology to not only improve from a long-term continuous improvement perspective, but also to facilitate faster operations of those value chains as they remove paper from their processes. A few of the key challenges when looking at this are, I have disconnected and disparate silos of information currently, or I have data that's lost or duplicated. Again, going back to the mountains of data that are causing the fractured enterprise in manufacturers today. It's those silos of data that are duplicated in multiple different systems that cause confusion, and that can cause a slower reaction time. So the next technology that's really going to be disruptive in the future is blockchain. And while we're not going to go into a significant amount of detail, it's worth mentioning because it's allowing companies to digitally interact with secure contracts that are enabling both better uses for smart connected products, as well as resolving traditional challenges like verified gross weight that manufacturers are now being on the hook for. And to give a quick example of the verified gross weight issue, if you look at traditionally companies that are shipping product, a manufacturer would rate their container shipment at a certain amount of weight, and that weight would mysteriously change as it went through several different port operations. And it would mysteriously change because the freight forwarders would pay different rates based on the amount of weight. By leveraging blockchain, any changes that are made to the initial weight will be seen by all parties, and most importantly, the party that makes that change will be understood because it can't be changed in the future. The point of change is able to be found rather quickly through blockchain mining. The next technology that's really posing disruption is artificial intelligence. And while there's multiple different types of artificial intelligence, 7 to be exact, there's a couple that we're going to talk about. And that's machine learning, and a subset of that, which is event processing and predictive analytics. Other types of AI includes natural language processing, which if you have a smart home device like Amazon Alexa, that's a good example of natural language processing. Speech processing, expert systems, planning, scheduling, and optimization tools. artificial intelligence that's limited in robotics and machines, and then of course vision AI, which is typically used in image recognition tools. But we're going to focus on machine learning and event processing. And while those are two of the older forms and more commonly used forms of AI, it's how the technology is advanced and how it's being democratized so that everyone can use them is what's really driving disruption from this. And what I mean by that is previously, if I wanted to create a predictive model, I had to have a data scientist take data, convert that data into a model, test the model, and then deploy it. And it was a long process. More importantly, data scientists are kind of expensive simply because they know a lot about math, more so than the common person. And when you're looking at a predictive analytics model, you're looking at how do I understand and predict outcomes based on patterns of behavior. And those patterns of behavior are then operationalized in a streaming analytics engine. And it looks at, okay, what's happening in the environment? How does that compare to the model that's inside of me? And how can I generate alerts off that model at speed and scale? It's the creation of these models from a predictive and complex event processing perspective that, again, has traditionally been the barrier to adoption, which is why companies have looked at how can I obtain data scientists and how can I do this faster. I just wanted to provide a quick example of what complex event processing looks like. And in this example, we're looking at 4 different variables: vibrations, voltage, temperature, as well as revolutions. And so this could be a compressor, if you will. And how this works is if I'm looking at a specific moving average, or when it moves outside of this moving average, and I also want to compare this to what's happening with my vibrational equipment, as well as the energy that's consumed at a single point in time or over a period of time, then I want to be able to generate an alert. And that's where, when I'm looking at this over a specific period of time, and I'm looking at all of these variables together, that is the key to a complex event processing tool that can also run predictive analytics. Traditionally, it's been difficult to create these particular business rules. You've needed an IT person to actually complete the interface, as well as you need a data scientist to work out the algorithms that are needed to do this. Well, interestingly enough, a disruptor, if you will, a disruptive company is Dürr. And Dürr makes robotic paint booths for the automotive industry. And they have implemented a tool that enables their field technicians to create these very complex algorithms through simple drag and drop GUIs. And the reason for that is their technicians have worked on these paint booths for years. They have the direct knowledge to know how to optimize them. And by giving them that ability to optimize those particular paint booths, gives them the ability to look at these particular, gives them the ability to optimize those booths for their customers quickly, easily, and without IT support. And they were able to do this because they had a drag and drop graphical user interface for non-coders. They had their domain experts, which were their technicians, and they were able to leverage a library of pre-built analytic blocks that they can also customize and specify. And then as the technicians were able to work with these particular models, whether it was on the edge or in a central environment, they could activate or deactivate particular algorithms based on how their particular piece of equipment was performing. So what did this do for Dürr? Well, it allowed them to first off take data from their robot arms and create the traditional digital twin of that piece of equipment so that they can understand centrally how this was working. They were also able to take that and work with their traditional data scientists to create predictive algorithms that were then deployed to an edge device so that they were taking approximately 65 readings every 8 milliseconds and pushing it into those predictive algorithms. Those predictive algorithms were working both on their own and in concert with the complex event analysis that was being construed by their individual technicians. And that allowed them to perform extraordinarily complex calculations on the edge in milliseconds, so that as their robotic painting arms were working, they could do a couple different things. And the first was they use approximately 50% less paint on a standard size automobile than they used to. Number two, they were able to detect quality defects extraordinarily quickly. So instead of having to detect a defect after 3 cars have been painted, they were able to find defects in very, very small areas, which meant less rework for the automotive OEM and lower costs. And most importantly, because they had this digital twin technology, they were able to innovate their product. And one of their innovations was coming up with a paint booth that uses 90% recycled air. And the reason why that's important is as this air that's coming out of a paint booth gets pushed into the environment, it has to go through a pretty rigorous cleaning process. So the more air you can keep in the booth and reuse to actually paint automobiles, the less expensive that booth is to operate. And again, this was done because of Duer's capabilities of being able to operate both on the edge as well as in a central environment where everyone, engineers, data scientists, salespersons, could use the information for what they needed in terms of what their initiatives required. So we covered a significant amount of capabilities and digital tools, and it's easy to focus on a single aspect or to have difficulty in implementing them because it's difficult. It's a lot of technology. It's a conceptual change for an organization. So what Software AG has found is there's kind of a specific methodology to go about in terms of building these capabilities. And that focuses on, number one, being able to focus on monitoring and diagnostics of specific individual pieces of equipment in a plant, and then expanding that out, as well as focus on specific pieces of equipment at customer sites first. Then again, continuing to expand throughout the entire ecosystem. Secondly, after just having that simple monitoring or dashboard view, be able to focus on how do I now look at condition-based alerts that are geared towards maintaining equipment, not on a time-based term, but on a condition basis. The third step focuses on enabling that digital twin. So sharing that data in the organization to simulate changes to drive either new product creation, to share it with your CAD and as well as your engineering teams, as well as to drive simulations and changes on equipment that is in use in your production facility or at your customer site. And so this time, when to really be able to scale this, a digital thread has to be construed. And it should focus initially internally on your own internal applications, then spreading to your suppliers to facilitate B2B communication, and then lastly, integrating your IT and OT systems together. While you're going on this journey, it's possible that some companies can circumvent some of this if they want to move straight to prediction and look at how do I begin reducing end-of-line tests? How can I use predictive analytics? And the reason for that is some companies already have the data that's needed to create predictive algorithms, as well as the data coming off of their test equipment that are ingrained into their production lines. And that allows for companies to begin with this type of predictive analytics. If you can't, I recommend starting this after you've created a digital thread so that you have this information readily available. Incrementally, if I'm looking at how do I look at smart energy management, how can I predict outcomes based on my maintenance requirements, since I've got my predictive chops in order for my end-of-line test reduction? How can I begin monitoring and managing equipment based on a predictive quality perspective? And then the holy grail, if you will, how can I have my equipment self-optimize itself? So I'm moving from a predictive analytics model to a prescriptive model, where not only are our outcomes predicted, but the root cause of those outcomes are predicted, so I can automatically intervene to ensure that I'm able to have those outcomes obtained through digital manners of changing my inputs, and I don't need someone to do that manually. And while that's a lofty goal, the last portion of self-optimizing equipment is a longer journey, and many companies candidly stop before they get there, or see that as a much longer term evolution. So from a creating disruptive perspective, the other aspect is looking at strategy, and this looks at, again, we focused on what are the technologies, how do I use the technologies. But from a disruptive creation perspective, there are 5 key dimensions to look at. And the first is speed. And while being first to market is great, being a fast follower still generates significant value. And a McKinsey study showed that fast followers even received a revenue uptick of 5.3% just by being fast. Secondly, companies need to be bold with their thinking. Challenging the status quo isn't good enough. But to quote a traditional Steve Jobs quote, the customer doesn't know what they want until I tell them what they want. And that's part of this particular strategy, is not creating and selling something that satisfied problems from yesterday or even today, but visualizing what the future is going to look like. And while this sounds lofty, it's actually fairly difficult, but it can be done. And most marketing and engineering teams have the ability to do this today if they had a little bit more data. The third area is focusing not just on a singular disruptive issue, but being able to look at it from a multidimensional perspective and enacting it on a multidimensional perspective. So if you're implementing a smart connected product, don't just think about what it can do for the product or the revenue that it can produce based on services, but look at how can that impact my entire supply chain? How is that going to impact the entire value chain of my organization? So if I want to move to a, like Gardner Denver, Air as a Service model, what's that going to do for my equipment financing program? What's that going to do for my working capital needs internally? And how can I work with my suppliers? How can I work with my ecosystem, which could be a financing company, to ensure that that occurs? And for those companies that are able to come up with bold multidimensional strategies, McKinsey has reported that results in an extra 12.3% increase in revenue. So now we're talking about real money here. And then lastly, it's also suggested to make sure that the organization is aligned in a clear direction, that everyone understands that direction, and that you're able to execute as well as possible. And the executing as well as possible is a little bit of a nebulous term. But what's great about this is you don't have to be world-class in executing to drive value. And again, according to our friends over at McKinsey, even if you have average execution, you're still going to be able to generate an incremental 7.1% increase in revenue based on your bold, multidimensional strategy that's well aligned. So the last point of the presentation is, who is Software AG, and why have you paid attention to this great webinar this time? Software AG is a German software company, and we've been working with over 281 manufacturers in over 72 countries. We have about $1 billion USD in annual turnover, and we've worked with several large manufacturers. More importantly, Software AG has been trusted to power leading industrial IoT platforms like Atomos, Siemens MindSphere, and the Bosch Cloud Foundry. We're happy to be a part of those. So that's the end of our discussion point for today, and I hope there are plenty of questions that have been entered into the Q&A and chat window. So right now, back to you, Katie. Thank you.
Thank you so much, Sean. So we do have a couple of questions that have come in through the question box. I just want to remind all attendees that you're welcome to continue submitting questions while we're doing Q&A for the next few minutes. Additionally, if you'd rather just ask your question live, go ahead and leverage that raise hand function through GoToWebinar, and we will unmute you so you can ask your question. But the first one for you, Sean, is, are enterprise digital twins widely used, and can they be used on smaller functions like a factory?
Yes, so enterprise digital twins are actually fairly widely used. And the other name that conflicts with the term enterprise digital twin is called an enterprise management system. And so either one of those two particular aspects or two particular terms are usually interchangeable based on the underlying technical capabilities. The second part of the question, yes, a digital twin can be used on a large enterprise from an end-to-end perspective where it yields the most value, but it can also be used on, say, a individual factory, and it can be used from I have multiple different production lines laid out. I want to understand how those production lines are operating, not just the pieces of equipment individually, but I want to look at the entire production process, from inbound supply to in-plant logistics to outbound product completion, so that I can understand how that process works, as well as be able to simulate changes to that process to understand outcomes.
Great, thank you. We have a second question here that says, APIs were not mentioned. Shouldn't they be considered a disruptive technology?
Yeah, so that's another good question. That APIs are absolutely in use today and are the wave of the future as well. But I kind of consider APIs at this point to be table stakes, if you will. Companies should have an API strategy in place. They should be moving forward with leveraging APIs both internally and externally. And APIs are not only a strong part of a internal integration program, but also are leveraged as part of that key direct to consumer market initiative. So for example, if I want to make my product catalog available for consumers, maybe I want to put that in an app somewhere, and I want any app to be available for this information. A good common example that I like of this is I fly United a lot. And the United app allows me to book Uber directly through it. And that's because there's an Uber API that's being accessed by my United app. And so every time I want to do that, I open a single app, I book my Uber to and from O'Hare, and I'm all set. And that's an easy example. Other examples can be, again, perhaps if you're a consumer products company, you want to go direct to consumer, you can drop those products into another company's app that has access to the consumer, or create your own app that's accessing your own product catalog through your individually created APIs. Thanks for that question, Katie.
Perfect. All right, it looks like that's it for questions, which is great timing because we should wrap up here in the next couple of minutes. So first of all, just thank you, Sean. Thank you, Software AG, from everyone at the MXD team. We appreciate the partnership, and we appreciate you leading this very enticing webinar today. I think everybody got a lot out of it. For our attendees, thank you all for attending this morning. I know webinars there are lots of them these days, and so we appreciate you prioritizing some of the ones that MXD is hosting with our members. We will be sending out slides to all of the attendees following the webinar, so you can keep a lookout for that. We also recorded this session, and it will be posted on MXD's website. So if you want to take a second look, or if you want to share with any of your colleagues, please feel free to do so. You'll be able to find that on mxdusa.org. You can see on your screen here, we've got another webinar coming up on July 8th that's going to be focused on cybersecurity, and a little bit of talk of CMMC, a little bit of talk of just improving your OT cyber maturity. And so I would encourage you to register and join for that. You can go ahead and click the link right on the screen there. And if you're just on audio, feel free to go again to mxdusa.org/events, and you'll be able to find the registration link right there. That said, again, I would like to thank everyone for joining today. I hope everyone has a great rest of their day and a great weekend. The organizers will stay on for the next few minutes just in case there are any last minute questions. And if anything else comes up and you have any additional questions or comments for Sean, please feel free to reach out to the MXD team directly, and we will go ahead and make sure that those get passed over to him. So thank you all, and have a great rest of your day.